Parallax is a visual memory and verification system for Codex. It records a real user journey through a website and saves what the user saw after every action. When the code changes, Parallax finds the first harmful visual difference, gives Codex-focused browser evidence, and replays the original journey to prove the repair worked. This controlled example shows the same point in two versions of a website immediately after the products menu was opened. In the failed version, the page became 92 pixels wider than the phone. In the repaired version, the same menu fits correctly with zero horizontal overflow. Parallax works as a visual safety net for front-end development. It records a real user journey, compares the saved moments, finds the first harmful change, gives Codex-focused evidence, and then replays the same journey after the source is repaired. The journey contains 4 actions. Open the site, open the menu, open products, and close the menu. Parallax runs these actions in Chromium at a mobile viewport of 390 by 844 pixels. After every attempted action, it saves the complete browser frame, plus the viewport document with overflow, console errors, intended click target, and the element that actually received the click. The first harmful change happened immediately after products was opened. Before the click, the menu fit inside the phone. After the click, the page became 92 pixels wider than the viewport. The heat map in the middle shows exactly which pixels changed during that action. Parallax then adds action context to those pixel changes. Blue identifies the control that the user clicked. Green outlines changed areas near that control. Pink outlines changed areas elsewhere on the page. These colors help focus the investigation, but the browser measurements remain the source of truth. Here, the submenu escaped the viewport and the next close click was received by an invisible element called close blocker. Codex does not receive every screenshot, every DOM node, and every log. Parallax chooses the smallest useful evidence package. For this regression, it selected the overflow report, the relevant heat map, the first harmful step, and the important before and after frames. Replay and factual proof. The repair only counts when the original journey passes again. Parallax replays the same 4 actions without rewriting the workflow. The failed document was 482 pixels wide. The repaired document is 390 pixels wide. In the cross-revision heat map, the bright magenta strip represents the 92 pixels of overflow that disappeared after the repair. Before the repair, the close action failed. After the repair, it passed. The responsibilities remain clear. The human defines the intended result. Parallax records and measures the browser. Codex reasons over the focused evidence and changes the source. Codex can divide a saved screenshot into labeled grid cells and request operations such as moving, copying, deleting, or replacing an image area. Parallax validates the coordinates and creates a rough mosaic preview before any real React HTML or CSS is changed. Parallax gives Codex visual memory, focused evidence, visual planning, and proof that the final user experience still works. I used Codex throughout the development of Parallax as my main coding and reasoning partner. With GPT 5.6, it helped me design the architecture, build the Playwright workflow recorder, create the visual comparison and heat map tools, develop the evidence selection and replay verification flow, debug issues, improve the interface, and prepare the final demonstration.